If you just remember the boron atomic number, you can find the rest of the elements atomic number by just adding the what 8, 18 and 18, next 32 and 32, F14. Let's look at the order. So boron is having the what? So but we are getting little bit lesser than X value you are getting. Why you are getting less value? If you just remember the boron atomic number, you can find the rest of the elements atomic number by just adding the what 8, 18 and 18, next 32 and 32. And what is the general electronic configuration of the group 13 elements? NS2, NP1. And these are belongs to the which block of the chemistry? Which block of the periodic table? P block. Why? Why do we consider them as a P block elements? Because the last electron is entering into the which orbital? P orbital. That's the reason why these are belongs to the which block? P block elements. And let me ask one question in this. The boron, aluminum, gallium and indium, thallium, in which element d orbitals are entering into the electronic configuration? So in which of these elements d orbitals are first introduced? Gallium. In the gallium only, na, you are getting the 3d10. First d orbitals are entering into the gallium, and next first f orbitals are entering into the what? Thallium. So because of this D and F, so we are getting the different properties for them. What are they? We will discuss in the properties place. So next let's understand atomic radius. So what is the atomic radius order of this group 13 elements? Generally in the group what happens? Top to bottom atomic radius. So top to bottom. So what will happen to the atomic radius? Atomic radius increases because of why? Because of what? Shell number increases. Because of the shell number increases. But expected order is what? Boron, next what? Aluminium, next gallium, next what? Indium, and next thallium. But this is the wrong answer. This is not the correct increasing order. Then you have to do little bit change. You can see the experimental value. Tell me the order of this atomic radius. Boron, gallium and indium and thallium. Aluminum. Only one change. Boron, gallium, next what? Aluminium and indium, and next what? Thallium. This is what expected. Why? What is the reason behind this? Why the gallium atomic radius is decreased? What is the reason? Because in the starting of this only I asked in which element you are getting the d orbitals, I said, right? Gallium only. So you remember this Poor shielding effect. So what is the order of the shielding effect? S is greater than, P is greater than, T is greater than F only, na? So can I say d orbitals are poor shielding effect? So they will show poor shielding. So as a result of the poor shielding, the attraction between the nucleus and outermost electrons increases. The attraction between the nucleus and the outermost electrons increases. As a result, what happens to the atomic radius? Atomic radius will be decreases. So if you look at this boron, aluminum, gallium, the gallium is having the electronic configuration is what? 3d10, 4s2, 4p1. See this, we are getting the d orbitals. So d orbitals are poor shielding. They are showing the poor shielding effect. As a result, radius will be what? Decreases. And this kind of decreasing the radius of the gallium by poor shielding of this d10 is called as decontraction. Is called as what? Decontraction. As a result, what will happen? Radius is slightly decreases when compared to the what? Aluminum. When compared to the what? Aluminum. Right now? Clear? So next one is ionization energy. Generally, what is the ionization energy order? Generally, tell me. So boron, and next what? Aluminum. Decreases or increases? Top to bottom. Decreases. Aluminum next. Gallium next. Indium and next what? Thallium. But this is not the correct answer. Because of the same reason, poor shielding of the D10 and next what? F14. Let's look at the order. So boron is having the what? So boron is higher value. The next, what is the next one? No. You are getting, yes, you are getting what? Thallium. So after the thallium, What is the next element you are getting? So after the thallium, look at for the 579. This is a boron, this is aluminium, and this is what? Gallium, this is indium, and this is thallium. So you are getting the next highest value is for what? Gallium. The next one is what? Aluminium, and next one is what? Indium. So if you look at this correct order, two elements are changing their values. What are these two elements? Thallium and gallium. So why gallium is having this different order? Because of the what? Poor shielding of the D10, and as a result atomic radius decreases. As a result ionization energy will be what? Increases. Because ionization energy is inversely proportional to the what? Atomic radius. When the atomic radius is decreases, ionization energy will be what? Increases. So gallium we understood because of the D contraction. But in case of thallium, you are getting what? 4F14. So 4F14 is introduced in the thallium. So this is also what? Poor shielding. Yes or no? So poor shielding. So poor shielding causes what? Atomic radius slightly decreases when compared to this whatever the we are expecting experimentally, that value is lesser than this. So we are expecting somewhat X. Okay. So but we are getting little bit lesser than X value you are getting. Why you are getting less value? Because of which contraction? D contraction is for gallium, not for thallium. That is F14. This is called as lanthanide contraction. This is called as what? Lanthanide contraction. So this is called as what? Lanthanide contraction. So if the shielding effect is, poor shielding effect is due to the D10, that is called as D contraction. If it is due to the F14, that is called as what? Lanthanide contraction. So thallium is having the which kind of contraction? Lanthanide contraction. As a result, what happens? Its atomic radius slightly decreases, and its ionization energy value will be what? Increases. But thallium is not decreasing like gallium. So just it is whatever we are expecting, it is not that much of high value. So slowly it is slightly it is decreases. Right now, clear? So next one is what? Oxidation states. So let's take this. What is the general oxidation state of this boron family? General oxidation state plus 3 or plus 2. So two elements, two oxidation states it can have. So let's look at this. What are they? NS2 and what? NP1. If this one electron is going, we are getting which oxidation state? Plus 1 oxidation state. If these two and this one, all these electrons are going, then you will be getting what? Plus 3 oxidation state. So why I am talking only about the NS2 and NP1? Because in chemical bonds, only which electrons involved? Outermost electrons only involved. That is the reason I am talking about NS2 and NP1. So if only NP1 electron is involved in the reactions, then you are getting the what? Plus 1 oxidation state. If all are involving like NS2 NP1, you are getting what? Plus 3 oxidation state. So just now we discussed for thallium case. So thallium is having the plus 1 is more stable than plus 3. So thallium is having the plus 3 oxidation state is less stable. So this is having the what? Less stable. And this one is what? More stable. So that, what is the meaning of this? The meaning is thallium don't want to lose the electron from NS2 and NP1. It can lose only from where? NP1 only. Why? Just now I said lanthanide contraction, poor shielding of F14. As a result, these electrons. So before this, let me know which electrons are closer to the nucleus. The electrons present in the s orbital or the electrons are present in the f orbital? SR. Penetration power is more for S greater than, P greater than, D greater than, and F. So s orbitals are very closer to the what? Nucleus. So that means these electrons are very closer to the nucleus. Why? Because of the poor shielding of what? 4F14. So because of the poor shielding of 4F14, the NS electrons are closer to the what? Nucleus. So as a result, what happened? These electrons don't want to involve in the bond formation. Why? What is the reason? Because these are very, very closer to the what? Nucleus. Now can you remove these two electrons easily? No. But these electrons are little bit far. so they can involve in the bond formation, they can easily lose these electrons. So the point is, and this phenomenon is called as what? Inert pair effect. This phenomenon is called as inert pair effect. What is the inert pair effect? Simply it is the involvement of only NP electrons are there for bond formation, not NS electrons, because of the poor shielding of 4f14. As a result, these NS electrons are closer to the what? Nucleus. These electrons are closer to the nucleus. Now tell me why thallium is showing only +1 oxidation state. What is the reason? Inert pair effect, right now? Inert pair effect. So next one is relative stabilities. If you look at here, +3 oxidation state stability top to bottom is decreases, +1 oxidation state stability top to bottom increases. So if you look at for thallium, thallium is having the +1 is more stable, but if you look at for aluminum, +3 is more stable. So higher oxidation state stability decreases, lower oxidation state stability increases. And next, if you compare this +1 versus +3 oxidation state, so which will be forming the more covalent compounds? Let's say one element is there in this one, aluminum is there. Let's say aluminum is having +1 oxidation state, let's say +3 oxidation state. In this, which will be forming the more covalent compounds? Why +3 form the more covalent compounds? How can you say that? What is the reason? Yes, correct. Good. Listen here. So oxidation state increases of cation. Oxidation state of cation increases. Its size will be what? Decreases. Polarization will be what? Increases. As a result, character. What happened to the covalent character? Covalent character increases. Covalent character increases. That is the reason why higher oxidation state makes the compounds more covalent than lower oxidation state. So in case of higher oxidation state, what will happen? Cation size will be decreases, polarization increases, covalent character increases. Let me ask one more question. So +1 oxidation state and +3 oxidation state. So which can have the more ionic character? +1 oxidation state or +3? +1, because +3 is having the more covalent. So +1 should have the what? More ionic character you are having. Right now? So next one is electronegativity order. Generally top to bottom electronegativity will be decreases, but this for boron family higher electronegativity you can see for boron, and the rest of them are having the nearly same value. Slightly differences are there, that is 1.5, 1.6, 1.7 and 1.8. So next, the nature of the metals, nature of the elements. Let's look at this. Boron is here considered as what? Non-metal, and next the rest of them is considered as what? Metals. So top to bottom, which character decreases and which character increases? Metallic character increases, non-metallic character decreases. Correct. So we will discuss these things. Before that, you complete this whatever we wrote.